2. This is going to be case 3. Okay. That is case 3. Case 3 is when we have repeated eigenvalues. Okay, repeated eigenvalues. In your case, because you just didn't get the 2 by 2 one, you try to solve the equation, you get a complicated square. Lambda 1 all square equal to this or something like that. Okay, so there you are. Suppose you have a repeated one. Suppose lambda 1 is equal to the lambda 2 is equal to the lambda is repeated. Okay, it's going to be a repeated eigenvalues. Okay, eigenvalue, and of course, K is going to be its corresponding eigenvector. K is its corresponding eigenvector. Okay, you know that quickly we can find one solution. E to the lambda t is going to be one solution. So then we can have the first solution, we call it x1. X1 is equal to, as we did it the other day, k e to the lambda t. This is going to be a solution. Is going to be a solution of the system. Okay, of the system. Our system is what is ax equal to the x prime in the matrix form. Now the problem is the second one. If in the usual linear equation, remember this is e to the lambda t, so t e to the lambda t must be the other one. But we have to modify it in vector form. So this is a suggestion, then we are going to prove it. A second solution. Okay, a second solution can be found. And we found up the form, we give a suggestion and then we prove it. This is going to be the suggestion. See x2. X2 is going to be is like it, the one that we did for the equation. K t e to the lambda t. Okay, but you have an extra vector here, plus an uppercase P for a vector. Okay, P e to the lambda t. This is the suggestion for the second solution. Usually factor out the e to the lambda t, so we write it down as kt plus p e to the lambda t. Okay, so this is a suggestion. And if the first solution is going to be k e to the lambda t, the second solution would be of this, okay, of this type. So we want to force this one to be a solution of the system. In order to be a solution of the system, see, so we have to find the p. In order to be a solution of a system, it must satisfy the system. Okay, so where p is going to be a vector, that you have to find it. Where the vector p, okay, to be determined. Okay, to be determined, so that of course x2 is going to be the solution of the system. X2 is a solution of the system. So for x2 to be solution of the system means what? Means so we should have x2 prime is equal to a times x2. Okay, that's condition to be solution. Let's form this one. Bring the x2 prime, the x2, substitute in this equation and solve for p. And that'll give you the formula that you're going to be interested in. Okay, so let's differentiate. This is x2. What's going to be the derivative of x2? See, differentiate respect to the t. Differentiate respect to the t, so that gives you x2 prime Okay, that's it. So that give you x2 prime is equal to what? X2 prime is just differentiate the first one. You differentiate respect to the t. So you have to use the product rule. Derivative of the first times second, second first. So the derivative of the first would be k e to the lambda t. Okay, plus derivative of the second times first. Derivative of e to the lambda t would be lambda e to the lambda t times the first would be k t lambda e to the lambda t. Okay, it's derivative of the first times second, second first. We continue plus derivative of the second one. The second one, p is a constant. Derivative of e to the lambda t would be p. Okay, would be p lambda e to the lambda t. That would be your, okay, your x2 prime. So substitute in this equation. So we are going to have what? We should have k e to the lambda t, repeat it again, plus k t lambda e to the lambda t plus p lambda e to the lambda t equal to, okay, it's going to be equal to the ax2. It's going to be ax2, this is it. It's going to be, a is like a function, okay, but in this case, you know, composition function or the product here, so multiply together. So that give you a k t e to the lambda t plus, okay, plus a p e to the lambda t. Okay, so x2 is going to be the solution of a system if it satisfies this equation. You see, e to the t is going to be a scalar and a non-zero number, so we can drop it. Divide by e to the, okay, e to the lambda t, because you know that this is never zero. So focus on the leftovers. To get these leftovers together. So the way I'm going to simplify it is going to be, okay, let's write it down, then we simplify it again. So it's going to be, we have a lambda plus k plus kt plus p lambda, and this is going to be a kt plus a p. Okay, this is going to be the leftover. So let's pull everything to one side of the equation. Okay, I'm going to pull these to the other side. It doesn't matter the direction. So I'm going to have AKT plus AP minus K minus KT minus P lambda equal to the 0. Okay, just move these to the other side. Yes.
Is that supposed to be KT lambda or just KT?
Which one? Oh, yes, yes,
okay.
yes, you are right. KT lambda. So this is KT lambda. Thank you. Okay, KT lambda. Let's simplify it a little bit in this form. So look at these two, this one over here and this one over here. There is a t, we can factor out the t, okay, and put them together again. So this is going to be something like put the t out here. Okay, that's going to be t out. So the leftover is going to be a k minus lambda k, if you like. Okay, that's it. And the rest, I just write it down together. Okay, so the leftover is going to be, I have AP minus K plus lambda P equal to the 0. Okay. Now, so let's make it better. So what I'm going to do, I'm going to factor out the K here. So it's going to be T times. I write this one as A. Okay, A minus a lambda. Remember, this is a matrix. You cannot write lambda as is, write lambda I times K. Okay, we make it lambda I to make sense. It's going to be two matrix, okay? So what can I do for the other side? I'm going to do the same thing over here. So this is going to be plus. The thing that I can do is I can do these, okay, these two together. Okay, these two together. Okay, so I pull out the P over there. So this would give me A minus, okay, A. This is, I pull out this one. So that give me A plus, just make sure that I didn't miss any sign. So
The P
this,
lambda,
which one?
the P lambda is supposed to be negative.
Oh, yes, thank you, because I need that negative sign. It's negative, that makes sense. Okay, so I pull out the P here. See if I pull out the P, so that give me A minus lambda I as well. Okay, and then minus K equal to the zero. Okay, I want to arrange it as a polynomial, if you like. This is going to be the case. Okay, now this equation, okay, is what? It depends on T. So this is true for all T. Okay, for all T. Since it's true for all T, it's like an identity. So what can I have is, to the left is a polynomial of T, if you like, a linear polynomial of T. On the other side, I have zero. So we can think about the other side as, you see, you can think about it as 0T plus zero, if you like. If you think about it in this form, then what are you going to have? So this coefficient must be equal to the zero. So the conclusion is going to be the coefficient of the T would be zero, which give you A minus lambda I times K equal to the zero. You see, that would be the coefficient of the T to the left, and the coefficient of T to the right is zero. On the other side, if you like, this is a constant term. This is going to be the constant term to the left, and the constant term to the right would be zero too. So the second part is going to be A minus lambda I times P minus K is also equal to the zero. Okay, any question? Just since it's an identity, so you want it to be true for all T. The only possibility is that the coefficient must be equal to the zero. So what I can do, I can move this K to the other side, and that will give me something nice, okay? So the conclusion is going to be, the first one is going to be A minus lambda I times K equal to the zero. That's the first one. And the second one would give you what? The second one would give you A minus lambda I times P equal to the what? Equal to the K. See these two equations that you have. So in order X2, as we suggested, to be a solution of the system, these two conditions must satisfy. You know the first one. The first one is the one that you use in order to find the lambda, to find the K, because lambda is your lambda is eigenvalues and K is the corresponding one. So from the first one, since you are going to get the K and the lambda, this will create the X1 for you, that you know it. X1 is K e to the lambda T. Okay, that's the first one. And the second one, from this second one, so you find the K, then you form this equation. There are vectors, P and the K. You can find the components of the P. So the second one would create what we are interested in, the one that we suggest, KT plus P e to the lambda T. Okay, so that give us the form of the second solution, and in fact, the way to find it. So the way to find the first one is we do the usual one, usual practice. As soon as you find the K, you come back. You come back, you form this equation. For this equation for the P, P is a vector P1 and P2. Then we can find it. We can find it, put them together, that give you the solution of the equation. Okay. So the general solution, okay. Again, we can show that this X1 and X2 that you got it from here are linearly independent. Okay, solution of the linear system, and since they are linearly independent, so the linear combination C1 X1 plus C2 X2 is the solution of the equation. Okay, so the conclusion is going to be X1 and X2 are, we call it fundamental solution in your book. Others are linearly independent. linearly independent solutions, solutions of the system, in the language of linear algebra, they are the basis, okay, a basis for the vector space of all the solution of the system. So, that's it, x equal to C1 x1 plus C2 x2 is the general solution. Okay, it's going to be the general solution of the system. And we're done. So that's going to be the case for the. Okay, so you have an extra job to do when we get to this case. You have to find the P. Okay, because you already got the K. You already got the K for one solution, then you formula the game, then you find the P, you put them together, and then you do that. Okay, this we do just system of two linear equations. You can do it for the 3, 4, 5. It's the same thing that you did before. Okay, that's it. Let's give you one example, and then we're done. Any question? Yes.
So in Zika's class, he uses lambda I minus a. Does it matter which one you use?
Lambda I minus a.
Yeah.
It's the same thing.
Okay.
Yeah, it's the same thing. In my notes, it's in fact it's that one.
Okay.
You can multiply by -1. Both sides. You want to be consistent with the way we write the metrics. That's why we go a minus lambda I. Lambda I minus a, both of them. Okay, so there you are. Let's do it. Example. Okay, example is what? Solve the system. Okay, this system is the following. We talk about it, they will give you in classic form or the vector form, which is more popular, or matrix form. 3, -18, 2, -9, and times x. That's it. You know that. You introduce the matrix of the coefficient and you go for it. This is your A. Okay, solution. So you pick the A to be just 3, -18, 2, -9. Go and find the eigenvalues. Remember, you have to find the determinant of the A minus lambda I, which is going to be 3 minus lambda, A minus 18, and 2, and -9 minus lambda. That's the determinant. That's why I go with A minus lambda I. So, okay, cross multiply. So that gives you 3, it's equal to 3 minus lambda times -9 minus lambda minus 2 times 18 between -36. There is a negative here, make it to the positive 36. Make sure don't miss this, okay, this sign. So continue for it. So that gives you -27 minus 3 lambda plus 9 lambda plus lambda squared plus 36. Write it down as a quadratic form, lambda squared. So that gives you 6 lambda and the plus 9. You can see it's a perfect square. So that gives you lambda plus 3 square, or just, lambda plus 3 times lambda plus 3. So you get the repeated solution here. Okay, so lambda equal to -3 is going to be a repeated solution. Two solutions, but they are the same. So as usual, continue find your your eigenvectors that give you K, and then come back and do the P. So what we're going to do is we have to find the K, remember? So this is it. You put there. So what is going to be your K? So the way we do it, you have to solve this equation. Remember, A minus lambda I times K equal to 0. Then for lambda equal to -3, this is going to be, remember we go to this one and we replace the lambda by -3, but we write it as a matrix form. So it's going to be 3 minus lambda, negative will be positive. I'll write it down so that you know it. Okay, minus 18, and this would be 2 minus 9 minus -3. Times that k equal to 0. Or if you simplify it, that give you 6, -18, and that would be 2, and that would be 12. 12 times it by k1, k2 equal to the 0, 0. We talk about it, both of them are the same, because if you multiply the second one by 3, you get the, okay, that would be, I'm sorry, that would be -6. So if you multiply, the second one by, okay, so that gives you -3. That is going to be the case. -18, -6, and this is going to be the case. Okay, so we talk about it. You just need to get one of them because I multiply the first one. So I give you 6k1 minus 18k2 equal to the 0. You don't have to form the general format. We know that the system is going to be dependent, because if you multiply by 3, you get the other one. So there you are, divided by 6. So that gives you k1 minus 3k2 equal to the 0. So you arrive at the k1 equal to the 3k2. So we have infinitely many solutions, just pick one of them. So I pick k2 is optional. K2 is 1, then k1 would be equal to 3. So I introduce the k. The vector k is going to be 3 and 1. Okay, any question? So we are ready to give you the x1. So the x1, first solution is going to be x1. X1 is going to be k, you see k e to the lambda t. So in this case, you have 3, 1 e to the -3t. This is of course going to be a particular solution. 3, 1 e to the -3t. Okay, any question? Now, since it's a repeated solution, you have to repeat it, but this time to get the p. In order to get the p, you have to form, remember, a minus lambda I times p equal to k. Get the other one. Okay, are you ready? So the next step is going to be finding the second solution. Okay, so there you are. The second solution, as we talk about it, x2 is going to be p plus kt, just remind you, e to the lambda t, and you have to find the p with this from this equation, a minus lambda I times p equal to k. This is how we're going to find it. So go back again to whatever we did before, a minus lambda I, remember, a minus lambda I is this matrix, 6 and -18, 6, -18, 2, -6. At this time, you have to multiply by p. P, you call it P1, P2, and this is going to be equal to the k, and you already got the k. Remember, k was 3, 1. Any question? So that a minus lambda I matrix is going to be the same as the previous one. Again, the same thing as you did for the other one. If you multiply it, that gives you 6p1 minus 18p2, and that gives you 2p1 minus 6p2. This would be equal to the 3 and 1. All of them are the same. You let them equal to each other to get the p1 and the p2. And this system is dependent. Okay, you just pick the first one or the second, but it doesn't matter. If you pick the first row, p1 minus 18p2 is equal to 3. If you pick the other one, multiply by 3, you get this one again. Okay, simplify it, divide by 3, so that gives you 2p1 minus 3p2 equal to the 0. Sorry, equal to, divide by 3 equal to 1. Okay, is going to be divided by 6. It's equal to the 1/2. Okay, And that's it. So you get
Is it 6p2?
6p1 minus 18p2.
Divide by 3.
I'm sorry, I divided by 6. I read them. I divide by 6, so that gives me p1 minus 3p2 equal to the 1/2. Okay, that would be easier to write down. Okay, so again, you get the infinitely many solution. Just pick any solution you like. Easy one. Easiest one is, for example, if you pick p2 equal to the 0, then p1 would be 1/2. Not infinitely many solution, it doesn't matter. Okay, so the one that I pick, p is going to be 1/2 and 0. That's p. Now we can give you the second solution. So the second solution is what? The second solution is of the form of the p plus kt e to the lambda t. Now you substitute, so your p is the vector 1/2 and 0. Plus k was 3 and 1, 3 and 1 t times it by e to the 3t, or the negative, yes, negative. So that gives you your x2. Okay, so the general solution, x is equal to the c1 x1 plus c2 x2, which is going to be equal to the c1. The first solution was 3,1, okay, 3,1 e to the negative 3t, and you get the c2 times it by this one, okay, 1/2 0 plus 3,1 times t e to the negative 3t. This is going to be the general solution of your system. Okay, so it's straightforward, and you get this numbers right away. Okay, any question? So we have the 3 cases. I give you one more. Sometimes we give you initial condition. So if you give initial condition, you have one more step to go. Find the C1 and C2. To show you how we find the C1 and C2, we should give you one. Okay, any question? So make sure you know your formula already. Just substitute the formula to get result. So one with the initial condition. See how we handle the last part. Let's solve this system. Solve the system. And this is it. The system is x prime equal to the 2, 4. Okay, 2, 4, negative 1, 6, x. And you have initial condition. See, x of 0 is equal to negative 1, 6. When they give you this one, remember, the first component is x of t, the second component is y of t. So this means x of t is equal to negative 1, y of t, x of 0 is equal to negative 1, y of 0 is equal to negative 6. Sometimes give you in vector form, or sometimes give you on classic one. Okay, there you are. Quickly get your matrix. Okay, there you are. The matrix A is going to be 2, 4, negative 1, 6. Go for the determinant. The determinant of A minus the lambda I is equal to, let's say, 2 minus lambda 4, negative 1, 6 minus lambda. Let's multiply to get the determinant. That give you 2 minus lambda times 6 minus lambda minus. This is a negative 4. Negative would be positive. That give you a positive 4. Will it? So that give you 12 minus 2 lambda minus 6 lambda plus lambda squared plus 4. So write it down in quadratic form. So that give you negative 8 lambda plus 16. Again, it's a perfect square. So it's a lambda minus 4 whole square. It's 0. So lambda 1, lambda 4, lambda equal to the 4 is a repeated solution. Repeated solution. Okay, that's going to be the first part. Any question? Go and find the K, the first solution. Okay, so the first solution would be of the form of the K equal to the lambda T. So we have to find the K. So to find the K, this is it. So find the K is A minus lambda I. It's just for information. You can do it right away. K equal to the 0. To go to the matrix, replace the lambda by 4. So write down matrix form. So that give you 2 minus 4, 2 minus 4, 4, negative 1, 6 minus 4 times K1, K2 equal to the 0, 0. So the matrix would be negative 2, 4, negative 1, 2. And both of them are the same. You multiply the second one by 2, you get the first one. So the matrix system is dependent again. You get one of them, I get the first one, negative 2K1 plus 4K2 equal to the 0. Focus on this one, divide by negative 2K1 minus 2K2 equal to the 0. So K1, 2K2. Take the K2 to be 1, and the K1 is going to be 2. So K is equal to the 2, 1. We have the first solution. Okay, so the first solution is going to be 2, 1 e to the 40. That is this one. Okay, we go get the second one. We find the P. Already getting the second one, create the P. Okay, going to the second one. So the second solution, x2 is equal to the, okay, it's going to be P plus KT e to the lambda T. We have to find the P. To get the P, you are going to form A minus lambda I times P equal to K. Okay, the first part is like the previous matrix that we did, okay? And the matrix was negative 2, 4, okay, and 1 and negative 1 and 2. Now it's a P1, P2 equal to the K. The K that we got was 2, 1. Again, you know, the matrix, the rows are the same. Just get the first one, negative 2P1 plus 4P2 equal to 2. Okay, just get this. Now divided by 2, so that we will negative P1 plus 2P2 equal to, okay, equal to 1. Let's pick a number. I pick the P2 equal to the 0. So the P1 would be negative 1. So P1, so the P that I pick is negative 1. Yeah. Okay, go back and write the second solution. So the second solution is going to be P negative 1, 0. It's KT, T times 2, 1. Okay. That is going to be the case, and all of them multiply by e to the lambda t, e to the 40. Okay, negative 1, I just check it, negative 1, 0, t to 1, e to the lambda t. Okay, any question? X equal to C1, X1, okay, C1, X1, C2, X2. So X would be C1, and your X1 is 2, 1, e to the lambda t, plus C2 times negative 1, 0, plus t times 2, 1, e to the, sorry, this is 40, 40. This is the general solution. But you have initial condition at 0. Find it at 0. See the initial condition. Initial condition is x of 0 is equal to the negative 1, 6. So you are going to put equal to the 0 in this equation because this is x of t. So you start with the negative 1, 6 equal to. Okay, put the 0 for the t. So that gives you C1, 2, 1. Replace t by 0, that would be 1. So plus C2 inside, that gives you negative 1, 0. Okay, replace t by 0, that will disappear. Okay, that's it. So this is what you got. So continue, simplify it, right? Because you have to the equality of two vectors or two matrices. So this is going to be the one that we have. C1, the first component would be 2C1 minus C2. Okay. Just adding these together. And the second component would be C1, okay, C1 plus 0. C1 plus 0. Okay. This is equal to negative 1, 6. So let the component to be equal to each other. You see these two would be equal to each other. And the other two. So the system is going to be the resultant system of the equation is the first one is 2C1 minus C2 equal to the negative 1. And the second one is C1 equal to the 6. In general, it's going to be a system of two equations, two variables. Use addition method to solve it. But this one is easy because you already got the C1. You substitute in the first part to get C. So that give you 2 times 6 minus C2 equal to the negative 1. So that give you 12. So negative C2 equal to the negative 1 minus 12. So negative 13. So C2 would be 13. Okay, that's the C1 and the C2. You go back, substitute here, and you present the solution. Okay, it would be 6, and that would be 13. Yeah, write it down here. So x is going to be equal to, which is x of t. C1 is 6. 6 times, okay, 2, 1 into the 40 plus 13. 13 times negative 1, 0, okay, negative 1, 0 plus t 2, 1, then e to the 40. It's the way we write it down. You don't have to simplify it further. Okay, so just give you the hint because we give you one of those 3 systems that are going to solve for us on this next quiz and the final would have initial condition. Yes.
How did we get negative 1 and 6 for x of 0?
It's
given.
given. This is initial values function problem. That's it. Any question? And go with the practice quiz. I give you your break now. Come back. We do the practice quiz number 4. You have 3 linear systems to solve for us so far. Linear system, and the other one is solving the system by applying Laplace transform.
I made it back just in time for the break.
Right.
It's very unprofessional, but I ran into La Jolla because of like May 4th deals. And then I got a lot of traffic on the way back.
Had to do it. It was worth it.
It was worth it. $100 discount.
Yeah, I just gotta some of these.
Was it just the the repeated solutions and examples?
Yep, exactly. Let me show the proof of the repeated proof or whatever, I don't know, however you derive it. Juan Martinez, right?
Yeah.
I sent you screenshots because for some reason my note taking app doesn't let me send files anymore, but screenshots.
Yeah. Less Apple.
I know, right?
Mustache monocle, very monopoly.
Sir, circumference, circumference.
I get it. Not anymore. Like whenever anybody asks me when my birthday is, I'm like, it's cow, and they're like, what's cow? I'll be like, exactly. Yes. Yeah.
Just
Hang out with dog. Alone.
some sad.
Notes.
Yeah,
You get handwriting, I can never do that.
mine is
Like it's like an art piece because I'm pretentious like that. It's like it's nice to look at, but it's like it takes a whole nother level of your brain to like know what's going on.
actually like.
Okay, there you are. For the quiz, we'll give you 6 questions. Okay, 2 topics, just solving the system of the equation. Of course, we give you one that you have to solve it using the Laplace transform. The Laplace transform, and the other are going to be just the linear equation that you're going to have, okay? And 2 are basic because they are homogeneous. We're going to see the non-homogeneous too, okay? So this Laplace transform one takes times, okay? So I tried the second one. If I get time, I'll come back and give you the first one to bet. When I post the lecture notes, I put all of if missed anything. But the rest are going to be straightforward, those eigenvalues one, okay? So let's check this number 2, especially it's a Laplace transform of the second order, not the first order. We didn't do any of this type, but you have some in your code. And there is one application problem. I try to, when you do the final review, I do one of them for you. Although we are not going to give you on the test, but we give you something so that you can see it. Okay, so there you are using the Laplace transform to solve this system. To see how we're going to handle this type. It takes time when you want to use Laplace transform, but it's unavoidable. You need it in the future, especially when you sort of go to the part of differential equation. Okay, so this is a practice quiz. Okay, practice quiz number 4. You have a couple of them on the final review. You can check that one too. So we want to use the Laplace transform to solve the system. This means you cannot use any other method. And it's not possible for this one. Use the Laplace transform. Okay, transform to solve the system. Solve the system. Okay, this is the system. Is x double prime. All the functions are function of t. Okay, so this is x of t. X double prime plus x minus y equal to 0. That's the first equation. The second equation is y double prime plus y minus x equal to 0. We have a bunch of initial conditions. The initial conditions are x of 0 is 0, y of 0 is 0, x prime of 0 is a -2, and y prime of 0 is 1. Okay, there you are. I changed the notation into the f of t and g of t. If you don't like it, in your case, this is lowercase. Some people, they go with the uppercase for the Laplace transform. And f of t, g of t is more popular. But you can use any notation you like if you don't like. Okay, this is the way I'm going to change it into there. So I'm going to suppose I'm going to suppose this is it, x equal to the f of t and y equal to the g of t are going to be solutions, okay? Are solutions of the system, okay, of the system, or the solution of the system with those initial conditions. Now take the Laplace transform of both of them as usual. So this is it. It's going to be the first one, Laplace of f double prime of t plus the Laplace of f of t minus the Laplace of g of t equal to the zero. That's the first one. Second one, likewise, Laplace of g double prime of t. Okay, g double prime of t, Laplace of g of t minus Laplace of f of t equal to this. Okay, now we change the system into the Laplace transform type. Now substitute the formula that we have. Remember, Laplace of f double prime is going to be s squared Laplace of f of t minus s f of 0 minus f prime of 0. So I'm substituting. So the first one would be s squared Laplace of, okay, Laplace of f of t minus s f of 0 minus f prime of 0. That's the first one. So it's plus Laplace of f of t minus Laplace of g of t equal to the 0. That's the first one. Then I apply the initial condition. We do the same thing for the second one. It's very similar. It's going to be s squared Laplace of g of t minus s g of 0 minus g prime of 0. Then you have a Laplace of g of t minus Laplace of f of t equal to the 0. We apply the initial conditions. F of 0 is 0, so that would be 0. G of 0 is also 0, so that would be 0. F prime of 0 is negative 2. G prime of 0 is a positive 1. Okay, so if we substitute, and the system would be easy to handle. So the result is going to be s squared Laplace. Remember, I'm going to do the simplified over here. I just factor out. I have a Laplace f of t and f of t. So I make it short. So I take out the Laplace of f of t. Okay, so this is going to be Laplace of f of t. Then the leftover here is going to be negative, positive. I get a positive 2. A positive 2 minus Laplace of g of t equal to this. That would be the leftover of the first one. Second one, I do the same thing, okay? Laplace of g of t. So that gives you s squared plus 1. S squared plus 1, Laplace of g of t. Laplace of g of t. Okay, this is 0, and this is going to be a negative 1, minus 1, minus Laplace of f of t. It's very similar equation that we have. That's it. You can move the 2 and the 1 to the other side, move it now or move it later, doesn't matter. If you move it now, it's going to be, this is one of the problem in your assignment. So it's a negative 2 and s squared plus 1 Laplace of g of 2 minus the Laplace of f of t. G of t, f of t, so f of t is equal to 1. Here you are. This is algebraic system now. Use addition method to solve for one of them. This one is very similar, both of them. Okay, to be want to eliminate it, you have to eliminate one of them. So, for example, if you want to eliminate f of t, we have to multiply the second one by s squared plus 1. If you want to eliminate the g of t, you multiply the first one. It doesn't matter. So I'm going to multiply. Doesn't matter which one of them. Okay. So let's multiply the first one by s squared plus 1 to eliminate. Okay. To eliminate the g. All of them are the same. Most of the work that you're going to see. So I multiply this one by s squared plus 1, so make it s squared plus 1 squared. Laplace of f of t. So that would be minus s squared plus 1, Laplace of g of t. And this is going to be equal to the negative 2 times s squared plus 1. Okay, and the second one. Okay, the second one, I rewrite it in this form, the negative Laplace of f of t. Now I have plus s squared plus 1, Laplace of g of t, okay, equal to 1. Now that gives you the chance to simplify g of t. Laplace of g of t will disappear. Okay, now you add them together, the leftover, and you work for solve for Laplace of g f of t. Okay, we add these together, so that gives us s squared plus 1 whole squared, Laplace of f of t, okay, minus Laplace of f of t, and on the other side, add these two together. Okay, so that gives me negative 2 times s squared plus 1 plus 1. Okay, there you are. Combine the like terms here, find the Laplace of f of t. So you're factoring out, okay, and then you simplify it. So if you factor out, this gives you s squared plus 1 whole squared minus 1. This would be the coefficient of the Laplace of f of t. Okay, that is going to be the case. And if you like, you can multiply that one and simplify it, or just do it later, it doesn't matter. It's going to be negative 2 times s squared plus 1 plus 1. Okay, you divide both sides by this expression, and that gives you Laplace of f of t, and then you start working. Okay, you can simplify this if you like. Maybe that would be better. It's going to be negative 2s squared minus 2 plus 1, which is going to be negative 2s squared minus 1. Okay, divide both sides. You get the Laplace of f of t, and then you can find the Laplace inverse, take care of f of t. Okay, any question? You may, that algebraic part, you do it different format, depends on the given problem, okay? So, are you ready? I'm going to divide by this quantity over here. Then if I need, I can square it, simplify it. So that gives you Laplace of f of t. It's going to be equal to, the top is 2s squared, okay? 2s squared plus, okay, negative 2s squared minus 1, okay, minus 1, and the bottom one would be s squared plus 1, s squared plus 1 whole squared minus 1. This is what you get over, okay, here. And to take care of this, okay? So f of t would be the Laplace inverse of, okay, the Laplace inverse of this function. Okay, now you have to decide what we're going to do, how we're going to find the Laplace inverse. Okay, we may simplify this one a little bit. I think that would be better if you multiply it. If you multiply that, give you s to the 4th plus 2s squared plus 1 minus 1. That would be helpful. And that would be negative 2s squared minus 1. We get s to the 4th plus 2s squared. You can pull out the s squared as a factor, and that gives you the hint of how we're going to find the Laplace inverse. Okay, so that's a negative 2s squared minus 1 on the top, and you pull out the s squared, so that gives s squared plus 2. Okay, so f of t would be the Laplace inverse of negative 2s squared minus 1 divided by s squared times s squared plus 2. So you have to work on this Laplace inverse to get this done. Okay, any suggestion?
Break it up.
Break it up, yes, very good. Break it up. So that gives you negative 2s squared minus 1 s squared times s squared plus 2 as negative 2s squared over s squared times s squared plus 2 and minus 1 over s squared times s squared plus 2. Okay, now the s squared would cancel out. This easily would be sine. Okay, so this is a negative 2 over s squared plus 2. You know that this one can be easily break out. So it's going to be minus, as usual, s squared plus s squared plus 2. You want to eliminate the s, remember? 1 and negative 1, try. It's going to be the leftover. That give you s squared plus 2 minus s squared. So the leftover would be 2. So we have to pick the 1/2 and the 1/2. Okay, you just put the 1 negative 1 so that you'll be able to eliminate the s and then coefficient. Yes.
I'm not understanding that shortcut. How do you get to 1/2?
You see, there is no s on the top. Okay, so whatever you do, you should eliminate the s square. So in order to eliminate this s square, when you add them together, you need two opposite numbers. You can pick anything you like. The easiest one is 1 and negative 1. So you put the 1 and negative 1, and you do it. When you find the common denominator, the top would be 1 times s squared plus 2. Then the other one would minus s squared. And when you simplify the top, you end up with the 2. And you want the 1. So you go back and you divide those 1 by half.
Ah,
See?
Yeah.
Because you have to cross multiply to, to remove the s squared. 1 negative 1, 2 negative 1, 2 negative 2, 4 negative 2, it doesn't matter.
Yeah.
So you do it, you end up with the 2, and you need 1. So whatever you do is you go back and you divide by 2. You get a 5 and 5. Yes, question?
Oh, I was just gonna say, what if it's not a 1, but it's the same thing?
Yes, yeah. Okay, go. Yes.
What is that method called?
Huh?
What is that method called?
Shortcut. No, this is the experience.
This is your method?
Huh?
Is this your method?
Yeah, this is experience. Yeah, we can do it all the time. Yeah, because this is so, so popular. It's happened all the time. So why not cross it off?
It's not- it's not even-
Yes.
If I wanted to check if I wanted to check to make sure I did that right, how would I do that?
Good luck. Don't try.
It'd be a long-
You have to put, you know that you have to put A1s plus A2, A1s plus A2. No, you check it by common denominator. That's the way to check it. You check 1/2 s squared minus 1/2 s squared would cancel out. 1/2 times 2 would be 1. 1. Okay, this is, it can be done when there is no s on the top. If it's going to be s, that can be done too, but it takes time. So in the case of differential equation, most of them are of this category. So why not? Just do it. It doesn't matter whatever number you have. We normalize it.
Oh, because it's that, you won't, okay.
Okay. So this is it.
Yeah.
That would be negative 2 over s squared plus 2 minus 1/2 over s squared. And negative, make it positive, that give you 1/2 over s squared plus 2. There you are. You are ready to take the Laplace inverse. I just apply the negative sign. So what's going to be the Laplace inverse? F of t is equal to, okay? I'm going to take the Laplace inverse of each. Let me write it down. The Laplace inverse of the first one. You know that the first one would be sine. But, if you like, you can write it as a -2 over radical 2. Create the radical 2 first. Laplace inverse of, just for your information, we do it right away. Really. This is what will happen to the first one. This would be 1/2. You know that this can be done easily because this is t. Laplace of t is 1/t². And the last one is the same thing. Okay, so this is going to be a plus. You have the 1/2, but you need that radical 2. 1/2 radical 2. Laplace inverse of 1 radical 2 over s² plus 2. But we do it in practice right away. Okay, for the sign, you need to bring those radical 2 because a² is 2, a square root of 2 would be radical 2. Now we are ready. So f of t would be -2 over radical 2 sine of radical 2t. That's the first one. Then this would be -1/2 of t because the Laplace of t is 1/s². And this would be again 1/2 radical 2. Okay, same thing. That give you the sine of radical 2t. How we can simplify it is like, yes,
I was gonna ask, when it's like that, do you still want us to simplify it, or can we just leave that?
this one?
Yeah.
No, you have to simplify it. Doesn't make sense.
It's like we could simplify it.
No,
It's
you
not-
have to simplify it.
It's mathematically the same thing
Yeah.
if we simplify.
So we have to rationalize.
Yes, but you have to simplify it. Yeah, we don't, we usually simplify it. It's very easy to simplify, nothing to worry about. It's like what? -2 plus 1. -2 plus 1, but -1. You see? F of t equal to -1 over radical 2 and of the radical 2t minus 1/2 of t. You see?
Should we multiply the one on the left by a 2 on?
Oh,
two over two?
I made a mistake, sorry about that.
That's why. no one's
Negative,
simplifying.
no. -2 plus 1/2. Okay,
Okay.
-2 plus 1/2 would be what? Would be -3/2. -3/2, that's it. Okay, I think we are done. Some people like to do the radical 2 things. You can do it if you like, but you don't have to. So if you want to do the radical 2 is going to be -3 radical 2/4. You don't have to do this. Sine of the radical 2 minus 1/2 of t as the final answer. Okay. So that the Laplace transform part is interesting for this one. So I picked this one from so that you can see that you can apply this one to the differential equation of a second order because we didn't practice second order. Okay, that's f of t. Yes,
Oh, never mind. Are we gonna find GOT?
of course, yes. We have to find the g. Okay, go back and find the g. There are different ways to find the g. You can do the same thing to get the g again, but there was a nice relationship between these when you put them together. Okay, and you see this one. Now you can use the first one and just substitute for the f of t. The first one over here, you have Laplace of g of t, even the original one. But this is it. I think this is the way I did it. So we are going to find the g of t. So I go with the first equation. We have different choices for this one. 1 plus s². Okay, Laplace of f of t. I have to rewrite it. It's minus g of t. Okay, minus g of t equal to, I think it was a -2. So we just substitute. So in this case, this is it. So g of t, if you like, g of t would be 1 plus s² Laplace of f of t plus 2. So we can substitute for the Laplace of f of t and then do the same thing. Get these numbers. If you want to substitute, you can use that easy form that we have, or just the original one. It doesn't matter. But I think if you do that part, it would be much easier to handle it. Yes.
I'm sorry, but where did you get negative G of t? Because wasn't it negative Laplace?
Oh,
G
Laplace.
of-
Laplace.
Oh.
Sorry. Laplace of G of t. You are right. Okay, Laplace of G of t. I think that's the way I did it myself. Okay, that was a -2. And this is it. Okay, so that's it. So one way to do it is this. So the Laplace of G of t would be, you see, this is what you have for your f of t. You see, this is the one. You just multiply here, that make it easier, okay, somehow to find it. See, we can simplify these two here. You see, these two, as we simplify the last part, it's just a negative, let me write it down for you. It's going to be 1 plus s squared times Laplace of f of t. And the Laplace f of t was a -3/2 over s squared plus 2 and minus 1/2 over s squared plus 2. That make it somehow easier to find that Laplace transform. Okay, then you have to break them again to get those ideas. So it's a -3. It's 1 plus s squared over s squared plus 2. Okay, and this is going to be minus 1/2. Okay, minus 1/2 times 1 over s squared over s squared plus 1 and the plus 2 eventually. Again, you have to break this part and that eventually be able to find it. I think that's the easiest way to do it. Get these numbers. They're not difficult. You see, it's going to be 1 over s squared plus 2. Then you have s squared plus 2 to get these numbers. Okay, so another method that I think about it for this. Okay, no problem. We can find it. Now you can, yes.
Since we, you solved for the Laplace of G of t, are we just allowed to take the inverse Laplace of both sides? Is that not allowed?
In this part is not going to be a good one.
Okay.
You take the inverse of both sides if the coefficients are numbers.
Okay.
If you take the inverse, you see your difficulty is going to be 1 plus s squared. Sometimes it can be done if the coefficient is constant. See, it's going to be constant, but you have 1 plus s squared Laplace of f of t. If you take the inverse of that one, you cannot pull out that 1 over your s squared plus 1. That's why I continue. Yes.
So I think it should be 1/2 s squared plus 1 over s squared, right? Because you're multiplying it in, or am I wrong?
Oh, yes, you are right. Very good. That's easier. Okay. We happily accept this one.
Thank you.
Because that make it very easy to do. Okay. Now, yeah, there you are. Now, you can break this one two parts or like integrations. When the degree of the top and the bottom are the same, you know that we divide the top by the bottom. That's easier to break it. Okay, because this is s squared plus 1, s squared plus 2. Or you can just use a trick of, okay, let me just show you, maybe do it in calculus, is this one, -3/2. You can divide it or you can write it down as s squared plus 2 minus 1 on the top. And this is going to be s squared plus 2. Okay, we have nothing to worry about this one. It's a -1/2. If you break it, this is going to be s squared over s squared, which is nicely 1. And this is going to be plus 1 minus s squared plus 2. So this is it. You break this one too, so that give you -3/2. You see these two over here. When you break it, that give you a 1 minus 1 over s squared plus 2, if you believe it. So that give you -1/2. And the inside would be 1 plus 1 over s squared and the 2. Now, all of them can be done to get your Laplace and Laplace inverse. Okay, even you can simplify it a little bit, and then eventually to get the final answer. Okay. So you have, if you want, you multiply -3/2 over here and -1/2 over here. -3/2 and -1/2 would be what? Would be -4/2, which is going to be -2, and the +2 would cancel out right away. You see these numbers? 1 is going to be -3/2, -1/2. That give you -4/2, which is a -2, and the +2 would cancel out. So the only thing that you have to find the Laplace inverse are going to be these two terms over here. Okay, so I rewrite it and take the Laplace transform. Any question? So you end up with another short form that you can give you this answer, but I'll talk about it later. So this is going to be the leftover. Laplace of g of t. Nicely, everything will cancel out. You get the 3/2 over s squared plus 2. Everything else cancel out. -1/2 times 1 over s squared. And that's exactly minus the other one that you got. So your g of t would be Laplace inverse. And that gave you 3/2. You want to go with the sign, you need the radical 2. Okay, radical 2, the sign of the radical 2t. And this is going to be 1/2, and this is going to be Laplace inverse of what is just t. That's it. So g of t would be 3/2 radical 2 sine of the radical 2t minus 1/2 of t. If you compare it with the previous one, this is just it is just opposite of the other one that you find. There's only a negative sign. Yes.
When I was doing this one, the 1 plus s squared over s squared plus 2, if you just break the fraction apart, you would get 1 over square root sine of square root 2t, then cosine of square root of 2t. Is that still right? But like I just did it a different way.
You'll be in trouble for the other part.
Okay.
Because the leftover is s squared over s squared plus 2. You can't do it.
Okay.
You need s. Okay, it's like integration. The way you do it, you have to divide the top by the bottom.
Okay.
Remember when you do partial fractions decomposition in algebra, if the degree of the top and the bottom are the same or is higher, you have to divide first.
Oh.
If you divide it quickly, you get it right away.
Oh.
Okay, that's that is that's the best way to do it for that. Okay, but eventually we get the solution. So these are just wanted to see they are not predictable when you go these. Even one of them, I just one of them with a constant coefficient. Once I was just giving a test, I said, okay, I didn't have time to make one or check it. So I saw one of those that you can use the eigenvalues. I just give them that. It must be easy. It was such a hard problem. You see, just doing it. It can be done, but not for the test really. So, but you get the experience. We try to give you one. It would be nice. This is nice, really. You have a couple of them in your book, which is not as nice as this one. Okay, so you just check the solution that I post for number 1, because it takes time to talk about that one too. So this is going to be the option, okay? And you have a couple of them in the final review. You can check those as well. Okay, maybe it's repeated. Look at the final review. You have the system that we ask you to use the Laplace transform is number 8. You see this one? This is the Laplace transform type. You see this? This can be done by this usual eigenvalues. And they ask you to use Laplace transform. Check it. It takes time. It can be done. And the challenging one is part B. Be patient and just do it. See how we can arrive at the solution using the Laplace transform. Of course, when you get the final review, we do it for you. But if you want extra problem, this is going to be the case, okay? So the rest, let's see if we can do quickly give you those eigenvalues for each one of them. The rest are just the usual practice that we have, 3 cases. Okay, so you want to solve a linear system. We call them linear system on the test. So this is going to be number, next page, number 3. Okay, number 3. On the test, we say solve the linear system. The linear system. You didn't ask for the Laplace transform, so you are free to use the eigenvalues and you must, okay? So this is the system, x prime equal to 1, -4, 4, we give you 3. Okay, complex eigenvalues, distinct eigenvalues, and the repeat. And you have initial condition as well, x of 0 is equal to 3, 2. Okay, just go for it. Get the matrix of the coefficient. So get 1, -4, 4, -7. Get the determinant of A minus lambda I. This one, 1 minus lambda, -4, 4, -7 minus lambda. Get the determinant. It's going to be equal to cross multiply 1 minus lambda times -7 minus lambda minus. That give you -16, but remember there is a negative sign here, so make it to the positive 16. Okay, foil it. So if you foil this one, that give you -7 minus lambda and positive 7 lambda squared and 16. Write it down in quadratic form. So lambda squared, lambda and 9. Yes, that is going to be the case. That's a lambda squared. Sorry, minus 6 lambda plus 6 lambda plus 6 lambda. And that's 9. So that is the solution, lambda plus 3 all squared. Okay, so get lambda equal to the -3 is a repeated solution. You have to go with the piece, okay? So we are going to find the first solution. The first solution, x1, is going to be k e to the lambda t. And the k, we have to find it from a minus lambda I times k equal to the 0, okay? So go to this matrix, replace the lambda by -3. So this is it. It's going to be 1 minus -3. We have a -4, 4, -7 minus -4.
-3.
-7. Okay, so that's 1. So that's going to be k1, k2 equal to the 0, 0. Let's get the first row, which is going to be 4, -4. We don't need this one. That would give you,
That's -3.
which one?
That -4 is supposed to be negative.
This
3.
one?
No, the other one.
This,
Nope, the other one.
this,
Yeah, that one.
okay? So that would be all right. Yes, that's it. Because we need a -4 again. Thank you. The row must be the same, or one of them must be the multiple of the other one, okay? So just get the first row, multiply 4k1 minus 4k2 equal to the 0. That give you k1 minus k2 equal to the 0, so they are the same. So pick a number, k2 equal to 1, so k1 will be 1. So k is 1, 1. Okay, k is 1, 1, and we can declare the first solution. So the first solution is going to be 1, 1 e to the 3, -3 lambda. So that's the first solution. Okay, any question? Now it's a repeated value. You have to get the second solution. We need to find the p. Okay, we're done. So looking for the P for the second solution. So this is it, the second solution. We have to find the x2. So the x2 in this case is going to be, okay, we get that P form. We talk about it. Okay, what's the P form? Is P plus KT, okay, e to the lambda t, but P coming from this equation. Okay, so A minus lambda I times P equal to the K. A minus lambda I, we already find this one. This is just 4, -4, okay? So it's going to be 4, -4, 4, -4. And we go with the P1 and the P2 equal to the K, which is 1, 1. Again, dependent system, let's just get the first one. 4P1 minus 4P2 equal to 1. Okay, you can pick a number if you like, divide by 4. P1 minus P2 equal to a quarter. So take the P2 equal to the 0, for example, and the P1 would be equal to the quarter. So the vector is going to be a quarter and 0. Okay, now we get the second solution, which is going to be x2 equal to the P1 a quarter and 0 plus t times k, t times 1, 1, e to the -3t. That is the second solution. So the general solution is going to be C1 x1. Okay, C1 x1, the x1 was 1, 1 e to the -3t plus C2, the one that we have here, quarter 0 t 1, 1 e to the -3. Okay, that's the general solution. And we have initial condition, we are not done. Okay, initial condition of 3, 2. So x is equal to x of 0 is equal to the 3, 2. So you are going to replace t by 0 in your solution, and you start with the 3, 2. 3, 2, replace t by 0. So that gives you C1, 1, 1, e to the 0 is 1, plus C2. Inside, this would be 0, and everything would be out. So we get a quarter and 0, 1. Okay, because t is 0, that we cancel out, e to the 0 is 1. So just write down first row, C1 plus a quarter of C2. The second row is C1 plus 0. Let them equal to each other, and you get a system. C1 plus a quarter of C2 is equal to 3. And from the second one, C1 is 2. That's it. You have the C1, you substitute to get the C2. So 2 plus a quarter of C2 equal to 3. So a quarter of C2 equal to 1. So C2 would be 4. Okay, so the final answer, x equal to C2, 2 times 1, 1, e to the -3t, and the C2 is 4. 4 times 0, and t, 1, 1, e to the -3t. You know, take a look at this one.